Hey guys, for this video I'm going to talk about the development of the heart and cardiovascular system. So to start off, when does the heart develop? Usually actually develops pretty early in the embryo. The only thing that happens a little bit earlier than that is the nervous system, and then the heart develops, but it develops relatively quickly, between 2 to 8 weeks. So it is susceptible early in development to defects, but if after it's developed, it actually is quite resistant to any defects after that. So 2 to 8 weeks, or approximately 20 to 60 days, you'll see development. Okay, so the first, before the heart actually develops, you'll see angiogenesis. So angiogenesis is basically the formation of blood vessels. So you'll see angiogenesis. It'll happen when the embryo is about 2 to 3 millimeters, and after it's like 2 to 3 millimeters big, it's too big for just diffusion to provide enough nutrients and oxygen. So when it's 2 to 3 millimeters, what you'll see is there's specific cells. They're called angioblasts, and angioblasts basically, when there is oxygen level is low, they proliferate. So if you see along the border here of the mesoderm, you get these, the formation of these angioblasts, and they will keep proliferating, and they can even join together, and you'll form below them, to fill up the space, will be blood islands, which actually come from the yolk sac. And what you can also see is there will be apoptosis occurs in the middle, and so you can actually see the formation of very primitive vessels. So there will be space in here for blood to flow. Okay, so that's how angiogenesis happens. So now for blood cells, it starts off, blood's originally made in the yolk sac, between 3 to 7 weeks. You'll see the yolk sac. Then it moves on to the liver. At approximately 5 weeks, it starts getting made in the liver, and then it finishes off around 24 weeks. You start to see it being developed in the bone marrow, so it slowly transitions between the yolk sac, the liver, and the bone marrow. Okay, now moving on to the development of the embryo. So if you look at the embryo kind of like from above, looking at it from above, and so this is like the head area, and the tail is at the bottom. What you'll see is actually in the middle, you'll start to see it's called the cardiogenic mesoderm. And this cardiogenic mesoderm is where you'll see the heart tube form. And so there'll be a left and a right side to this heart tube. Okay? And now, so if you look at this from the side, this heart tube will actually be quite high up in the body of the embryo. So if this is the ectoderm here, then you got the mesoderm formed, and then the endoderm's down here. The heart tube will be way up here. Okay? It's actually above the oral pharyngeal membrane, so where the mouth forms. Okay, so how does it go from here? You want this heart down here, right? Moving down. So there's forces that actually cause, as the embryo starts to roll on itself, they push down like this on the embryo, and they cause it to roll. And you'll also see if I cut through it like this, right? And I see the transverse plane, what you'll also see is it gets pushed inwards too. So if you got the two heart tubes here, so there's a left and a right heart tube, there's a neurotube up here. This also gets pushed inwards. Okay, and so what results is, so you got this heart tube that's at the top, and say the heart tube's kind of like over here. So you got the heart tube. It actually gets pushed down and inward, and so what you'll get is you'll get a left and a right heart tube that end up joining together. So you get these two heart tubes. You'll see it like this. And these two heart tubes ultimately end up joining together, and you'll kind of see it'll look like this, and it'll almost look like there's 4 chambers, okay? And this is a primitive heart, and so what this is often referred to as the 4 chambers of the heart. Okay, and so it looks like it has 4 chambers, but if you actually cut into it and looked inside, what it actually is it actually is one continuous tube. So there's actually just a dividing line like this, and actually is just one continuous tube that's open. Okay. So now, if you looked at this tube, so left and right, this way, what does it actually look like? It starts to look, so from front to back, if you cut through my body like this, it'll look like a tube that's bent like this. Okay, so blood comes in this way. This is the atrium. This is where the atrium will develop. The ventricle will be down here. And this is where the aorta and the pulmonary trunk will form. So the first thing that actually starts happening is you got to divide off the atrium from the ventricle. So you got this region here. These are called endocardial cushions. And these endocardial cushions basically start to come in and actually get squeezed. And they squeeze and they basically separate the atrium from the ventricle. So say this is what it looks like this way, and it gets squeezed in. It actually gets pushed in from the middle, like this. So then what you end up seeing is, if you look at it from the top, is it gets squeezed in, and so you'll end up with, or if you look at it from the top like this, it's squeezed in, you get a left and a right side. So if I draw that out, the left and the right side, is you'll get a structure like this. And so these are the endocardial cushions. They come from neural crest cells. And you'll get this section in the middle, right? So if you move it like this, it goes and it forms this endocardial cushion right in the middle from where it gets pushed in. Okay, so this will be the primitive right atrium, left atrium, right ventricle, and left ventricle. Okay, so very primitive. Now, how do you separate the left and the right side? First of all, what grows is you got the septum primordium that starts to grow from the top up here. So this is the septum primordium. And this basically grows down, you keep growing down, and it ends up extending all the way down to the endocardial cushion. So the endocardial cushion. Okay, but as it starts to extend down, apoptosis occurs higher up, and it leaves an opening. And this opening here is where the foramen ovale will form. So the foramen ovale is basically the shunt that allows blood to go from the right atrium to the left atrium and bypass the lungs. Okay, so that's the foramen ovale. So now the septum primordium is down here, and then the second one forms. It's the septum secundum. And it forms, and it basically goes just a little bit below the primary one and to the right side. And so that's septum secundum. And so basically the primary one ends up being a flap. It's a flap so that when blood comes, it can push this flap down and it can open up for the foramen ovale as a shunt. Finally, what comes up is you get the muscular region of the ventricle septum. So the muscular portion grows up from here, and then the membranous septum comes from the endocardial cushions, and also this here is the bulbous region, bulbus cordis, and so that also comes and contributes to the membranous septum. Okay, and so that's how that gets divided off in the left and the right ventricle. Finally, how does this section here get divided off? Basically, how do you divide off the pulmonary trunk from the aorta? And what happens is there's also pinching. So it could be pinched here and pinched up here. So up here is actually called the truncus arteriosus. Okay, so it gets pinched. It'll be pinched there and there, but it can be pinched in other directions. So this may be pinched on this way, here, to divide it off. So it would be pinched. So you could have it pinched here and then pinched up here. And so what you get is you get a spiraling effect as you go up. It spirals, and so that spiraling effect ends up, it allows for the crossing of the aorta and the pulmonary trunk. So the aorta kind of goes over like this, and the pulmonary trunk goes in behind. And that's how the twisting occurs. It's because it actually segregates, twisting all the way up between the bulbus cordis and the truncus arteriosus. Okay, moving on to the 3 shunts. So basically the infant, or the fetus has 3 shunts, right? To prevent blood from flowing where it doesn't have to. So you got the shunt to prevent it from going to the liver. You don't need it going to the liver because the liver basically processes the nutrients for digestion. And since the infant is not eating, it's getting all the nutrients from the mother. You don't need it going to the liver. So you got the ductus venosus, which basically shunts the blood from this is the placental vein. It shunts it from the placental vein and it bypasses the liver into the inferior vena cava, which goes into the right atrium. The other 2 shunts that you'll see is the foramen ovale, which shunts blood from the right atrium to the left atrium. So it bypasses the right ventricle and it bypasses the lungs. And you also have the ductus arteriosus, which shunts blood from the pulmonary artery to the aorta. And that also shunts blood away from the lungs. Basically, the infant isn't breathing, so it doesn't need as much blood perfusing through the lungs. So you got shunts that prevent blood flow to the lungs. So how does this actually happen? When the infant is in the womb, basically the lungs have fluid all in them, and so it's low oxygen levels. The O2 levels are very low. And so this low oxygen levels in the lung, it causes the arterioles to contract. So this is known as a hypoxic pulmonary vasoconstriction. So these arterioles of the pulmonary circulatory system are all contracted, so it reduces blood flow. So if there's reduced blood flow into the lungs, there's a backup of the blood when the heart's pumping. So this backup causes an increase in pressure in the pulmonary, in both the pulmonary trunk and also the right and the right atrium and right ventricle. So the pressure is increased here. What you also see is because blood is not flowing through the lungs, there's not that much blood coming through the pulmonary veins back into the left atrium. So in the left atrium, the blood pressure is actually quite low. And so what you'll see is because there's a higher blood pressure in the right atrium than the left atrium, blood can push this valve open and flow directly from the right atrium into the left atrium, essentially bypassing the lungs. What you also see is because the pulmonary artery is so high in pressure, blood will also flow from the high pressure to low pressure, so it'll flow through the ductus arteriosus into the aorta. Okay, now what happens during birth is what you'll see is there's two things that occur. The placenta is cut off, so the blood is not flowing through the placenta anymore. And also the lungs are filled with air. So what that causes is an increase in oxygen. So, let's start off with the placenta. So the placenta, blood does not flow through here. Okay, so now that blood is not flowing through, it won't be flowing through the ductus venosus. And basically, right after birth, you'll see that because there's no blood flow through the ductus venosus, it will close off, and blood will end up coming from the inferior vena cava into the liver, and the liver will be perfused with blood. This blood will then go to the right atrium. Now what happens to the lungs is the lungs have air in them now, so now the oxygen levels are high. This allows the arterioles to dilate. So the arterioles dilate in the lungs, and if the arterioles dilate, the resistance in the pulmonary system goes down. Basically, it allows for more flow. The resistance is lower now, so then the pressure drops. So the pressure drops in the right ventricle, and the pressure also drops in the right atrium. Now that the pressure drops there, and also what happens is blood is flowing through the lungs now. There's more blood coming from the pulmonary veins into the left atrium, so you'll see that the left atrium's pressure also increases. So the pressure increases in the left atrium. So now that there's a higher pressure in the left atrium than the right atrium, the blood wants to go back the other way. Basically, it pushes the flap down, and it closes off the foramen ovale. So right at birth, the foramen ovale closes. The other thing that happens is now the pressure in the pulmonary artery will be lower than actually the aorta. So that would cause backflow into the ductus arteriosus. So what the ductus arteriosus actually starts to close. It has smooth muscles around it. So it senses when oxygen is increased, flowing through the ductus arteriosus. It causes the smooth muscles to constrict. And another thing that happens is the placenta actually releases prostaglandins. And these prostaglandins allow the ductus arteriosus to dilate. Now that the placenta is cut off, there is lower prostaglandins, so that's another reason for the ductus arteriosus to close off. And so you'll see the ductus arteriosus starts to constrict, and it'll close off, and it'll become the ductus ligamentum. So now the last thing that happens, or last thing to talk about, is some defects of the heart.
Hi. So I'm sorry to disturb you, but apparently the volume is just a little bit loud. So if you could just reduce it just a little bit,
Okay.
that would be great.
Sure thing, I will.
Thank you.
Okay. Be a little quieter. Okay, so and now the last thing is talking about cardiac defects. So cardiac defects, the most common cardiac defects are septal defects. So you can get atrial septal defects and ventricle septal defects. So the atrial septal defects occur about 7% of the time of cardiac defects, and the ventrals are approximately 30% of the time. And the ventral septal defects can be divided into membranous. So basically, the hole in the heart between the septum occurs in the upper part of the ventricular septum, or the muscular, so at the lower part. So it's more common to occur in the membranous part, but it's more serious in the muscular portion of the heart. And basically, septal defects, they come in variable ranges of severity, just depending on where it occurs and also on how big the hole is. Moving on to other cardiovascular defects. So the first one we'll talk about is there's persistent truncus. So persistent truncus occurs when basically there was no segregation between the pulmonary trunk and the aorta. So basically the pulmonary trunk and the aorta are both attached to the right and left ventricle. So what you see there is because there'll be a mixing of oxygenated and deoxygenated blood. So because there's a mixing, you'll see hypoxia. And so what you'll see in the infant is if there's hypoxia, what you'll see is the characteristic baby blue syndrome, or blue baby syndrome. And so the infant will be blue. And the other thing that you'll see with this disorder is you'll see pulmonary hypertension. And this hypertension is because the left ventricle is pumping into the pulmonary artery, and so that will cause an increased pressure in the pulmonary circulatory system and thus pulmonary hypertension. So that's persistent truncus. The next one that you'll see is coarctation of the aorta. So coarctation basically means narrowing. So it's basically narrowing of the aorta, and this actually occurs at the ductus, where the ductus arteriosus was. So if I drew out the heart, and I have the aorta and the aortic trunk, what you'll see is there'll be stenosis right here. So there'll be a narrowing of the aorta, and then it'll widen up again. And so what that does is that restricts flow going down to the lower extremities. So it doesn't actually affect the upper extremities, just the lower extremities. So you'll see the lower extremities will have decreased perfusion, they'll be cold, all symptoms like that. And what you'll see, and also have a lower blood pressure. So you see low blood pressure here in the lower extremities, and you'll see a high blood pressure in the upper extremities because they'll be receiving all the blood, and because the heart will be working harder to try to compensate for the decreased blood pressure. So now another disorder that you'll see that's quite common is tetralogy of Fallot. So tetralogy of Fallot is but basically tetra means four, so tetralogy of Fallot. So you'll see four things that occur here. First one, there'll be a ventricular septal defect, so there'll be a hole in the ventricle. You'll also see overriding aorta. So overriding aorta is basically the aorta is actually positioned in a different place than it normally would be in the left ventricle. And because of that position, it's actually closer to the septal defect, so it receives a greater proportion of blood coming from the right ventricle. And so what you'll see is there'll actually be a higher proportion of deoxygenated blood coming from the right ventricle and going directly into the aorta. So this causes hypoxia. Another thing that you'll see is there'll be pulmonary stenosis. And so pulmonary stenosis is basically a narrowing of the pulmonary artery. So if there's narrowing That also causes less blood to go to the lungs, so this will also cause more hypoxia. And the last thing you'll see is because of the pulmonary stenosis, there'll be an increased pressure in the right ventricle, and so you'll see right ventricular hypertrophy. So because the right ventricle will have to work harder, the muscle will become enlarged, so that will cause the hypertrophy. So that's tetralogy of Fallot. So this also causes blue baby syndrome. And the last thing that we'll look at for cardiac defects is when the baby's first born, one of the first things that's checked is you actually check the umbilical cord. And there should be one vein and then 2 arteries. And the arteries are actually returning deoxygenated blood back to the placenta. Okay? But in single umbilical artery defect, if there's only one artery, it doesn't actually affect the infant's development, so the infant can still be healthy, but it could signify other developmental errors. So in 15 to 20% of the time, you can see what will happen is there could be heart defects, muscular defects, intestinal or kidney. So basically all these defects are associated with this defect. Okay.